Alright students, welcome back to Liam's AP Psychology course. My name is Liam Kim, a rising junior in Korea International School Jeju, and I'm here to support you on your way to get a 5 on the AP Psychology exam that you're going to take in May. Now, we're going to talk about the last half of Unit 1, Scientific Foundations of Psychology, as a continuation of the last video of our course. Now we're going to talk about Module 6 through Module 8 today. Module 6 is about correlation and experimentation. Now, a correlative study is when two things correlate if they are related to each other. And correlative studies are predictive, but they do not explain the cause. Studies that explain the cause are only experiments, not correlative studies. So this is really important. You need to remember this. So correlative studies can tell you, for instance, that lung cancer patients tend to be smokers. They tend to be smokers, but doesn't tell you that smoking causes lung cancer. This can be only identified by experiments. Causation is only available when you talk about experiments. Now, a correlation coefficient is a number between -1 and 1 that tells us how well they correlate. The higher the magnitude is, the stronger the correlation. So -1 and 1 is perfect correlation, and 0 is no correlation. Now, correlation relations are often shown through scatter plots, which makes it easier to see than in a table. So when you're in a math class, or when you're in a science class, or even in an AP psychology class, you're going to see lots of data. And all of those data are going to be shown through scatter plots if they are in a correlative relation. Now, as you can see in the images, a perfect positive correlation with +1 sign will rise up. The end behavior will rise up towards the right side, as you can see in the first image. When there's no relationship, the plots are going to be scattered on the graph. And when there's a perfect negative correlation, -1, then the end behavior of the graph will head down to the right side, right? As you can see on the third image. You all know how this works from your science and math class, right? It's just the same in AP Psychology. It's graphing. Now, correlation, they do not imply causation, as I emphasized before. So just because A and B happen together, it doesn't mean A causes B or that B causes A. And also, there may be a third factor involved. Let's say, for instance, that low self-esteem correlates positively with depression. Now look at the following diagrams for the possible causes. Low self-esteem could cause depression, or depression could cause low self-esteem. Now there could be a correlation, right? Or distressing events or biological predisposition could cause low self-esteem and depression. So as you can see from this description, 3 possible cause-effect relationships. People low in self-esteem are more likely to report depression than are those high in self-esteem. One possible explanation of this negative correlation is that a bad self-image causes depressed feelings. But as the diagram indicates, other cause-effect relationships are possible. So therefore, we don't know which of these 3 it may be. Illusory correlations, on the other hand, it's an illusion, it's something that's fake or non-existent. An illusory correlation is a correlation that we think exists, but actually doesn't. There are random coincidences that seem like patterns in this relationship. Experimentation is when descriptive studies only describe how things are. Correlative studies only tell us if A and B are related. They can predict, but not explain the cause. However, experiments allow us to isolate or control variables and allow us to figure out the cause and effect relationship between things. Now consider a hypothetical experiment. A pharmaceutical company wants to figure out if a pill called Sauron is effective at treating face cancer. There will be 2 groups in this experiment, one that receives the treatment or the drug. This is the experimental group because you want to experiment what this pill does to the group. Now, one that doesn't receive the treatment or the drug will be the second group, called the control group, to see that any potential healing effects don't occur without the drug. Ideally, the groups will be determined randomly through random assignment. Ideally, neither the experimental nor the control group will know which group they are in, which is called a blind study, to control for a possible placebo effect, which is when sometimes people get better just by thinking or knowing that they received a treatment or drug. Now, random assignment, blind study, and placebo effects, these are all measures taken in an experiment to root out all the possible biases that may be included in an experiment that may cause the result of an experiment to be unreliable and therefore be false. Now, this is why all of these factors that determine how reliable an experiment can be is surely important when you conduct an experiment. Another such measure is called the double-blind procedure. So for instance, sometimes even the research aides who distribute the medication and record the data will not know what group the patients are in. So the experimenters in the lab coats, they don't even know which group is the experimental group or which group is the control group, so that both the test subjects and the experimenters, they don't know which group got the real pill. So this will root out any placebo effects, right? Because both the researchers and the test subjects, they don't know if they are taking the real pill or not. So they won't be able to get better just by thinking or knowing that they received a treatment or a drug. So this will cause them to be surely frank about the actual effects that they had experienced through getting the drug. So this will highly boost up the reliability of the experiment. Now, in this experiment, whether or not you get the drug is called the independent variable. Because this is the variable that the researchers are changing, it can vary independently of other factors. And whether or not the patients improve is called the dependent variable, which is the y value, because this is the variable that varies dependent on the independent variable. So depending on the independent variable, the dependent variable, the result changes. Now we're going to talk about longitudinal and cross-sectional studies. Longitudinal studies are the same subjects studied over a long period. The advantage, number one, they can show effects of changes over time. Number two, they are more powerful than cross-sectional studies. Some disadvantages are, number one, they require large amounts of time. Number two, they are really expensive. On the other hand, cross-sectional studies are those that people of different groups at the same time are being studied. A cross-section of people at one point in time are being studied together. So for example, at the same time, a group of juniors and a group of freshmen could be studied over the same time or the same test agenda. This is called a cross-sectional study because there are two different groups that are being studied for the same time. The advantage is that it is quick and easy. Another advantage is that the results are generalizable because the test is being conducted on different groups, right? And this can highly be a factor of randomly assigning and randomly selecting group members and results from their tests, because different groups are being tested, and then you can get a really generalizable results because all the test subjects, they had different qualities and they are in different groups, so they may show a variance of test results, which will really represent how generalizable the results are. Some disadvantage is that it is difficult to find populations that differs by only one factor and that they cannot measure changes over time. The reliability and validity in an experiment. Reliability. Within the reliability branch, there's something called the split half reliability. So it is when the researchers randomly divide a test into two sections, and they correlate people's performance on the two halves. A correlation coefficient in this test section is when the result is closer to a +1, the more reliable it is. And the equivalent form reliability is when the test is available in several equivalent forms, and the correlation between performance on the different forms of the test are going to be represented. A test-retest reliability, this is a key vocab that you need to know. The correlation between a person's score on one administration of the test with the same person's score on another administration shows that the test is really reliable. So when you take the test one time, when you take another test another time, the results should be the same because that's how reliable the test will be, right? Because when a person takes the test I mean, the person taking the test could study more or like develop the qualities more and get a better result, but still, there shouldn't be a great disparity between the results because the same person is taking the test. Therefore, this thing called the test retest reliability, it should represent how similar the results of the tests were when the same person took the test. And the validity section. Validity happens when a test can be reliable and not valid, but not vice versa. So what this means, within the validity branch, there's something called a content validity. So this is how well a measure reflects the entire range of material it's supposed to be testing. And face validity is a superficial measure of accuracy. And there's also something called the criterion-related validity. And within this section, there's something called concurrent validity. And this measures how much of a characteristic a person has now. And the predictive validity is a measure of future performances. And construct validity is the degree to which a test measures what it claims or purports to be measuring.